Okay, hello, welcome to another GeogPod. We're going through the first side of distinctive landscapes today with myself, Mr. Unite, and Mr. Sahai is joining us today. Hello, Mr. Sahai.
Hello. Yep, looking forward to this one of my favourite topics.
Yeah, definitely. Like to get into the physical nature of the beast of geography. So we're going to kick off straight away. Okay, so I'm going to zoom in to my top left-hand corner, and we're going to just really quickly think about sort of what do we mean by the term landscape, and just introduce the idea about how we talk about relief of the UK. So simply, a landscape has visible features that we can see on the surface of the land, okay? And if you remember from the lessons, okay, we split them out into a few different pictures. So there was like a coastal one of the Jurassic coast, like there's a boat in the foreground, we talked about how weather may play a part. So the key thing for you to know here is that we mainly look at four key landscape elements. Those are physical, such as mountains, coastlines, rivers. Those are biological. So again, think about your science lessons, those that are living, whether that's flora and fauna, so habitat, wildlife, etc. Those that may be human, so the infrastructure, the roads, railways, that sort of stuff, but also the things that aren't necessarily built as such, the stuff that varies from place to place. So if I was to go to a coastline on a particular day and we're looking at what normally is a beautiful beach, but it's absolutely chucking it down, well, how does that maybe change that sense of that landscape element? What happens if I took you to a place and the smell and the sounds were really overpowering? So really key thing, okay, we might think about our key landscape elements as physical, biological, human, and variable. This then leads into our understanding of the relief of the UK. And effectively, relief is to do with the height above sea level. Okay, so in terms of some quick key terms, we have either lowland areas, mostly shown by this light green or this darker green sort of over here. Okay, and then in terms of uplands, typically shown by darker oranges and browns. Places over here would include like Scotland and places like the Cairngorms, the Grampians, and obviously the Cambrian Mountains in Wales. So all we're looking for really is a bit more detail in this. Okay, so what makes a lowland a lowland? Well, as you can see here, we've got the fens outlined. That is in part of the county of Norfolk. Mr. Sahai, I believe you're a Norfolk boy. That's correct, isn't it, sir?
I'm a Norfolk boy, yeah, mainly in Cambridgeshire. Really got Cambridgeshire.
Oh, okay. Well, we're a Norwich fan, aren't we? So yeah, there we go. So we're thinking about places around Norwich, Ipswich, etc. That sort of area where we've got generally flat areas or maybe some rolling hills. Okay, it might be warmer weather, which is why if you think about it, a lot of that eastern part of the UK is really good for growing crops because it's nice and flat and it's got that warmer weather. On the flip side, this long sort of central mountain range to the centre of the UK, known as the Pennines, including areas in Manchester, we can also think about those areas generally being above 600 metres tall. Okay, so we've got peaks and ridges, and obviously on those we might find cold and misty, perfect area for what we're going to talk about later in terms of freeze-thaw weathering. So just some things for you to think about as well. You should be able to name some lowland areas such as the fens, and you might also want to make sure you can name some mountainous areas such as the Cairngorms in Scotland, Cambrians in Wales, and obviously we've got the Cumbrian or the Lake District as you might know it, and the Pennines in the UK as some examples. But obviously with this, okay, yes, so go on. What you got?
How does geology then link up to this?
Excellent, sir. So what we want to try and think about
geology
really
link up to this thing?
Yeah, definitely. So I think for now, all of these different heights will of our UK, the relief of our UK, will fit nicely with the next two bits that we're going to go through. Okay, so we're going to look at glaciation in the UK and geology of the UK as well, and how that fits in. So yeah, Mr. Sahai, what do you want to carry on from there? You happy with that glaciation in the UK?
Yeah, definitely. I think geology is really important. If we look at that next, obviously the geology is so important in that it's the underlying rocks of the United Kingdom. And obviously, the type of rock is going to influence whether it's an upland or lowlands area according to the properties. So if we just go down, that's perfect if you scroll up there. You can see we've got three types. Hopefully you remember your igneous, your sedimentary, and your metamorphic rock. So important because if you look at where we've just been talking in the upland areas, you can clearly see that there's different colours there, okay, which are representing mainly igneous rocks. So if we look down the bottom, in Devon and Cornwall, we can see patches of red, which represents granite outcrops, which make up Dartmoor and Exmoor to the north. Obviously, up in Scotland, there's lots of red dots of igneous rock there, okay, and a few other belts going in there. And obviously, Edinburgh's built on those old extinct volcanoes. There's a reason why. Igneous rock is really resistant to erosion. So while other sedimentary rocks have worn away, those igneous rocks have remained tall, making up the landscapes of the mountains Mr. Unite's just discussed. And we've also got lots of metamorphic rock in Wales. So Snowdonia, is made up of a lot of slates, okay, where you've had metamorphic rock, which is basically rock which has changed, metamorphic, it's changed by heat and pressure into a more resistant, harder rock, and that's why it's surviving, okay? So I mentioned about granite as an example of an igneous rock. Metamorphic rock, a good example would be slate. Marble's a beautiful type. And then if you look in the southeast of England, so East Anglia down towards Kent and all on the bottom south coast there, we've got sedimentary rock. Now, sedimentary rock have been formed in millions of years of the crushed materials being squeezed together. Things like chalk and limestone, the popular ones. You obviously know about Pigston Hill, which is close by to here, and we're in the Chilterns. So you know that we're in an area where we've got sedimentary rocks. And they've worn away at a faster rate, hence why they're nice and flat. Now, just above it is another reason with the glaciation of why the UK is shaped as it is. So we had thousands of years ago ice sitting on top of most of the United Kingdom. It got down to about the Watford Gap, in case it didn't get right down to the bottom. And that heavy ice was miles thick in places, and it's just literally gouged out the landscape that we've got now. And we can see it through U-shaped valleys, where the ice has just literally carved its way through, taken no prisoners, and left those steep mountainy peaks. So really impressive if you ever get to go to Snowdonia or go up to Scotland, okay, to see the real difference. So the ice age has really shaped what we've got left behind in the upland areas particularly. In some of the lowland areas, it's glacial till, where material's been placed down after the ice has melted. It's left as unsorted material, really good for farming, because it's got lots of rich materials, particularly up on the Holderness coast, up above Hull, the Humber Estuary, we've got lots of good stuff there. So they're really distinctive areas of the United Kingdom.
Excellent, sir. So yeah, really good recap in terms of what we talked about earlier in terms of the upland and lowland areas, and then how glaciation and geology of the UK influences that. So that's two key things that feed into that really, really nicely. So just down in the bottom left-hand corner, you've got a tiny little bit of information that just links soils in, okay? So I'm going to keep this nice and simple, okay? So obviously our soils are created from those weathered rocks and materials, etc., that are being sort of eroded, weathered over long periods of time, okay? And again, like Mr. High was talking about how geology will influence and rock types will influence the height of the land, it will also influence the fertility of the soil. So as we said earlier, in that eastern region of the UK and southeast, very good for growing crops. You know, east you've got lots of what we're going to say. Oh God, I've heard the names here, like arable crops. You know, so like weeds and stuff like that in the Kent, etc. And they're even trying to get a few vineyards out there of grapes and stuff like that with that climate as well. But again, the key thing to really think about here is areas of lowland are generally going to have deep soil. Okay, where we've got lots of fertile, whereas our upland areas, a bit more like our rainforest, where we've talked about thin soil there, is because of that rock type, it hasn't had enough time to build up nice, deep, fertile layers of soil. Okay, so in terms of that, that's why when you go to places, in Scotland, the Lake District, where you see lots of sheep. If you go to the Lake District, you see lots of sheep called then named the Herdies, and they're really good for living in those areas because they can survive on that small amount of vegetation that's able to grow there. They're very adapted to it, so it's very good areas for using your animal crops and stuff like that. But in terms of those areas that have sort of the southeast, etc., have the deeper soil, much better for growing our crops, such as wheat. And again, how you might see this change is as you move around the country, you might see different trees. So deciduous trees are those that decide to lose their leaves when we get to summer through winter, etc. They gain them again sort of springtime, and they lose them in the autumn. Whereas in our upland areas, we're more likely to see our coniferous, our evergreen trees as well. So just a little link in terms of how soil and landscape feeds into those particular areas there. We've got one final little section that's going to get us thinking about the landscape before we start to think about, climate and weather in the UK. So, Mr. Sahai, in terms of human activity on the landscape, what sort of things generally happen in the UK? What sort of major changes do you want to be aware about?
So obviously, you'll understand that the UK is very different now to a couple hundred years ago, when the UK would have been covered with far more trees. We've used our woodlands, okay, we've used them for lots of reasons, from building to originally a source of fuel. And obviously, that's gone, partly because of our industrial development and using those materials, but also because of our increasing population. We need space, not just for housing, where people live, but for all the infrastructure, putting in roads, putting in the pipelines, the pylons to move the stuff that we expect to have delivered to our houses around the UK. Now, obviously, along with more people is the need for food. Mission United's just been through the type of farming, the arable farming we found around us in this area because of the soils. Obviously, we're lucky. We can get machinery, combine harvesters worth millions of pounds onto the land here because it's nice and flat. But as soon as you go out to Wales and northern England and Scotland, you just cannot use machinery. So obviously that shapes what we can actually do within there. One of the real pressures, though, is the fact that in our search for more land, we're trying to move into areas that we shouldn't really be there. So the Cambridgeshire Fens, which we talked about, is actually below sea level. And we've actually physically drained them as people. We've got pumps in there, okay? We've drained those areas so we can make use of them, mainly for farming, but also for people to live there. But the real problem at the moment is the concept of urban sprawl, okay? We are spreading outwards. Our towns and cities are joining up together, and we're really having to be careful to make sure we keep distinctive areas of landscape, which are still rural, okay? Rather than just putting more and more buildings and factories and all the things that we need to support us on there. So our human activity on landscape is having a big impact.
Yeah, really like that, sir. And when we talk about that urban sprawl, I know that myself and Mr. Hatchell did some bits on urban sprawl, collaborations in your urban futures bit. So we should now be building up that confidence to start to see how bits we've done elsewhere start to link into some of the other little sections that we've done as well. Okay, so in terms of climate and weather in the UK, okay, as we know, essentially we have areas that have lots of rainfall, or what we might call precipitation, and areas that don't have as much. This is shown really nicely by this diagram and map over here, okay, where the darkest blue is where we have the highest percentage of rainfall, and where we have our lowest levels are sort of the white areas. So what we want to try and think about really is those areas that have the most. In the UK, obviously, we get a lot of prevailing wind from the southwest or across the Atlantic Ocean. So that brings lots of warm, wet weather over to the UK, which can be dumped onto the land in the form of precipitation. What that means, though, and we've talked about relief rainfall in sort of a previous section, but we start to find that as it gets pushed up towards the mountains, effectively, in simple terms, the water is released over those mountainous areas. It doesn't necessarily reach those further parts in the east. And we also know that in terms of that height, okay, that's the key bit for our weather there. Okay, so what I want you to think about really is in those same areas where we have our upland with lots of precipitation, we start to find certain processes start to happen. Okay, and in particular, where we've got the altitude increase, we also find not just changing rainfall, but also changing temperatures. For sort of roughly, I think it's about roughly each mile it changes by around about a degree. Mrs. High, feel free to correct me there. But yeah. Yeah, excellent. So what we can start to find is we start to have processes of weathering, and in particular in those areas of upland areas, freeze-thaw weathering is significant. Okay, so I'm going to talk about that one just very quickly first of all, and we'll come back to these other ones later. But just to remind you, freeze-thaw weathering is a process, so we call it a mechanical form of weathering, such as those by rain, frost, and wind. There is also another one called onion skin weathering, which you might come across, but we mainly focus on freeze-thaw weathering because it applies very nicely to the coastal and the river sections that we do later on. So really simple, okay, in our sort of upland areas, obviously some water may then gather within a crack. And as that sort of gathers in there, at night as the temperature plummets, okay, it will freeze. And what's important is that when it freezes, it can expand by about or up to around 9%. As you can imagine, this then means that that crack, that fracture, will increase in size. And as it thaws the next morning and then through the next day, that water will disappear. And we'll find that the whole cycle will continue. And then eventually, the crack will continue to widen. And we may even find that this rock breaks in half totally, or this part of rock will break off and fall down. So what's really key, just to remind you here, is our weathering is the breaking down of material. When we move on to our erosion, we're going to talk about the idea of how material is worn down, its shape changes, etc., and it changes or sandpapers some of the landscape around it. But for weathering, it's all about how processes break down that rock that we've been talking about. So that's mechanical in the form of freeze-thaw weathering. For chemical, okay, the key word really, oh, go on, sir, go for it.
Yeah, that freeze-thaw is what's going to ruin our roads over the winter, because we have that constant freezing and then that constant thawing, which keeps happening day, night, and breaks up our roads and causes a lot of issues. But basically, that concept of weathering is in situ. The Latin word for in situ is not moving anywhere. It's getting attacked by the physical, the mechanical forms of weathering.
Yeah, excellent. Great use of key term there, sir. Yeah, in situ, really, really nice. So again, with this, okay, we find chemical, in particular, some of you might remember some of the limestone sort of images that we've had in lessons, you know, of sort of either gravestones or statues and buildings that are limestone, and how through sort of that acidic rain or those sort of elements going on, that chemical change will in particular dissolve that rock and change the shape of it. Okay, and again, as Mr. High said, in situ, so changing that shape of what we can see within that landscape. For biological, again, we talked about, you know, think about your biology lessons, you talk about living plants and animals. So two ways we might look at this, okay? One, animals such as rabbits might dig down into the rock. In particular, when I've been to the Jurassic Coast, you know, I saw sort of along Old Harry, loads of rabbit burrows, etc. And you can see how they're going to help to break down that rock and weather it over time. But on the flip side as well, ones that you've probably definitely seen around in your local area is where we find tree roots or other sort of roots that will break up through the surface. You know, I'm sure you've definitely gone past in a car, walked along a surface where a tree's roots has sort of come up out of the concrete. You know, that really shows you the power that these weathering materials are able to do, and why significantly weathering and erosion has such a changing shape on the UK's overall landscape. And as Mr. High and I have talked about so far, you know, when we think back to the glaciation and geology, that helps to create those distinctive features throughout the UK. So onwards from this, obviously we've talked about weathering so far, but Mr. Zahai is going to go back through the sort of sister, if you so wish, to weathering, erosion. Sir, what we got?
Yeah. So with erosion, we've got agents of change. We've got the concept of something moving. Okay, usually it's water, so we can think about ice, we can think about rivers, we can think about coastal areas, we can also think about wind, but we've got to have something moving, so it's not staying in one place with erosion. Now, erosion, you've just got to learn these terms. Okay, there's 4 terms. Okay. Some of you have seen me do this in class. We've got the actions for the different ones. So attrition, okay, is where you've got rocks bashing against each other, smashing in and going to smaller pieces. They smooth as they grind against each other. Solution is where it dissolves. So any material that's the water's going over the top of will dissolve it. Think of chalk and limestones. Abrasion is where material is rubbing against the base of a cliff or the bed of a river. So it's a sandpaper effect. If I rub my fingers together, you can feel that friction, okay, developing. And then hydraulic action is the crashing of water, compressing air in a cliff, or again in the banks of a river, compressing air in there, causing it to expand, and also that continual process breaking things down. So erosion is the way in which water, in our case, we're looking at rivers and coast, actually break down the environment around it. The rock gets broken down, it's obviously changed, it's made smaller, and it's used to further wear away the landscape. Once it's been broken down, then it can be moved. And transportation is the next 4 terms you need to understand. Thankfully, one of them is already done. So solution, if it's already been dissolved in water, it's already been carried in the water. So it's the same as erosion. It happens at the same time when that occurs. We've then got traction, which is the first one, where you've got that rolling motion. Okay, now this is going to be big boulders, which can't be picked up easily. So it might take a surge of an extra wave or a flood condition of a river to actually turn material, and it turns around and around. So traction, think like traction of, you know, a tractor and its wheels turning and moving heavy material. We've got the next one, which is the bouncing, saltation. Okay, so the river will have enough energy to pick up a pebble for a moment, it'll lift it, and then it'll put it back down. And again, lift and put down. Same with the concept of waves, moving material, pick it up and then putting it down. Lots of material is light enough to get suspended. So we've got suspension, where essentially material is churned up. You can see the colour in rivers and the sea now and then when it's churned a lot of material up, and it's just suspended. It's held within there. So particles of sand, particles of mud, just held within the water, and it will obviously float along in that water till something changes. And then the last one, okay, we mentioned about solution again, where it's dissolved. Now, all of this moves material from one place to another. So with rivers, it might be from the upper part of the course of the river to the lowland course, and obviously in coast, you know how it moves along the river, along the coastal stretch. But the key thing is, it'll only transport it when it's got enough energy. So when there's enough wave power, enough river carrying it. Obviously, if it can't carry it, it will then put it down, it will deposit it. Okay, deposition is the final bit. Erosion, transportation to move it, and then deposition. And we'll come to look at that when we look at some features in a moment.
Excellent. Yeah, the deposition bit is just on the next page. So yeah, we are going to move to that, but it's going to be a bit weird that we've talked about it. But there's one other sort of part within this section we're going to bring to your attention, okay? And that's all about mass movement, okay? And what's really key here is, again, you know, like Mr. High talking about here, there's a few key words, you know, like carried, bounce, etc. We really want to make mass movement nice and simple as well. Okay, so there's a nice little diagram here as well. You might want to try and think about how landslides and slumping are some particular examples. The image that we're looking at here is essentially slumping, as you see by that where it says that slumped mass. Essentially though, mass movement is any large movement of soil and rock debris, okay, down slopes. But when you just talk about it in that sense, okay, that's quite basic. So can we try and make sure we're using the idea that gravity plays a role in that, and that those processes we talked about earlier in weathering and erosion will help this to happen? You know, if we've got freeze floor weathering or animals burrowing away, that's going to weaken that rock and allow it to move. We've also got that hydraulic action that may well be undercutting and eroding some of that rock that is underneath certain parts, okay? But for mass movement in particular, this slumping here, okay, we've got a nice 4-step scenario, okay? One, our rain saturates the permeable rock above the impermeable rock, which makes it heavy. As I'm sure you can imagine, even if I gave you a sponge and put some water in it, you get that idea that it can hold the water in the sponge, so it's permeable, it takes the water in, and it becomes heavier as well. So if it's adding that weight to it, and we've got that gravity working on it, it's creating that potential situation where we might see that slipping. But what's also going on at the same time, okay, is that the waves or the river will be eroding the base of the slope, what we might call undercutting. Okay, so you might recognize that word from cave arch stacks and also from the formation of a waterfall. So all of that will go on. In particular, a hydraulic action and abrasion are going to be really significant here. Eventually, the weight of that rock that is now above it is getting heavier as it becomes more and more saturated and weakened beneath it. It will eventually weaken and collapse. And like, you know, if I said to you slump in your chair, it's got that sort of rounded movement. That's what we'll expect to see here. And that's what really defines slumping, is that curved motion. Okay, so you can really see how that debris at the base of this cliff here has now been moved down. And in particular, when we go to your case studies and water on the naze in our next GeogPod, you'll really start to see how water on the naze is a great example of areas that do slump. And then once all this material is gathered at the bottom, okay, it can then be removed and transported by our waves or rivers, okay, in those 4 methods that Mr. Sahai talked about: solution, suspension, traction, and saltation, which will mean that these materials be moved away and we begin our next sort of stage of the journey, where we start to think about deposition in the next slide. So, Mr. Sahai, that concludes our little bit here. Any final thoughts before we wrap up?
No, I think you covered all the different terms. Important terminology there to remember, because if you know this stuff, then you can apply it to the case studies, which we'll be looking at next.
Yeah, like that. So really good, nice quick summaries. And like we said, we're going to get to ready for the next GeogPod on side 2 of distinctive landscapes. So thank you very much for joining us. We hope that was helpful for you. As always, if you have any further questions, give your teacher a message. Otherwise, obviously, any member in the geography department will be happy to help. But otherwise, good luck with your revision, and we hope that was helpful for you.
Yeah.